Hello, and welcome to Nature Connects, TNC in Massachusetts webinar series that connects you with scientists, experts, influencers, and our partners from New England and around the world. Thank you for joining us today. I'm your host, Tricia Jedele, Offshore Wind Policy Manager for the Nature Conservancy. I developed TNC's offshore wind work to meet our climate, conservation, and community goals. Climate change refers to a change in the state of our climate that persists over a long period of time, typically decades or longer. We know that there is climate variability due to natural causes, but there's also climate change that is caused by human activities. This climate change is one of the most significant threats to species survival and habitat, and this is especially true in the ocean. Modeling shows us how much we have to do to reduce carbon emissions caused by the burning of fossil fuels to avoid the worst effects of human-caused warming on nature and people. This is where we get our net zero carbon emissions by 2050 goal. Given the number of people we have on the planet, energy demands, the need for energy reliability, and our land constraints, studies tell us that offshore wind will have to play an outsized role if we're going to reach our climate mitigation goals. The global goal for offshore wind is 380 gigawatts by 2030. And on the Atlantic coast here in the US, we are on track to build almost 50 gigawatts by 2040. But the topic of offshore wind is a complicated one. Just saying the words offshore wind often evokes many different opinions and feelings. There are so many questions and concerns about offshore wind, especially when it comes to what it means for our economy and our communities, and how it will impact the species and habitats that we care about. TNC launched this offshore wind webinar series to bring you experts who can provide accurate information to some of the most common concerns and frequently asked questions. During last month's webinar, we talked about how to think about the cost of offshore wind contracts and how to view that pricing in the context of other considerations, like making sure we have heat in the winter and what it costs us to buy backup fuels like gas and oil, and the public health costs that come from burning fossil fuels. If you'd like to watch that webinar, we will drop that link in the chat. During today's discussion, we're going to focus on the approach that the federal government uses to find the best areas for offshore wind. In the United States, the federal government is responsible for identifying areas that are suitable for energy development in the ocean. This includes oil and gas production, other energy projects, as well as offshore wind. The states, tribal nations, ocean users, coastal communities, and other interested parties like TNC contribute information that helps the federal government find the best locations. The ocean is a dynamic environment. Species patterns and ecosystems are constantly changing. Collecting information in the ocean and interpreting it to inform our decisions is difficult, expensive, and often time-consuming. This means that sometimes we have a better idea about how species use habitats and the habitats themselves in some places in the ocean than we do in others. Because we need to know a lot more about these important ocean spaces and how animals use them, but we also need to build offshore wind in time to mitigate the worst effects of climate change. Decision makers need to use the best information available now to make decisions about where to locate these projects. Today, we're going to talk about how this is done. It's my pleasure to introduce you now to our speakers. Our first presenter is Dr. Seth Theuerkauf. Seth is a Renewable Energy Program Specialist with the Federal Bureau of Ocean Energy Management. We'll use the acronym BOEM when referring to this agency today. Seth is an expert in technical approaches to marine spatial planning. He will explain how BOEM uses data and the information the public provides to identify areas in the ocean that are suitable for offshore wind. Our second presenter is Dr. Jocelyn Runnebaum. Jocelyn is a marine scientist with the Nature Conservancy's Maine chapter. She works with university scientists, resource managers, and industry partners to improve the overall ecological health of the Gulf of Maine. Her expertise is in fisheries management and habitat modeling, and she's going to talk about how TNC engages in the BOEM process. As you think about questions for Seth and Jocelyn, please enter them in the Q&A box at the bottom of your screen. We're going to hear both presentations before we take questions. Thank you all so much for joining us today. Seth, I'll pass it on to you now to get started.
Wonderful. Thank you so much, Tricia. Let me get my screen share going here. Alrighty. Well, thank you again, Tricia, and thank you to the TNC team here for the invitation to present today. As Tricia shared, my name is Seth Theuerkauf, and I'm a Renewable Energy Program Specialist with the Bureau of Ocean Energy Management, or BOEM, within the Department of Interior. Today, I'm going to be sharing with you all one critical component of BOEM's Renewable Energy Program, and that's really focused on identifying the best, least conflicted locations for offshore wind leasing. So who is BOEM? So BOEM's mission under the authorities of the Outer Continental Shelf Lands Act is, as well as the Energy Policy Act of 2005, is to manage the development of energy, mineral, and geological resources of the United States' Outer Continental Shelf, or OCS, in an environmentally and economically responsible way. So that includes management of sand resources for beach renourishment projects, as well as oil and gas and renewable energy resources. In total, BOEM manages almost 3.2 billion acres of the United States' Outer Continental Shelf, spanning from the U.S.'s East Coast to Alaska to the U.S. territories. So I am focused within BOEM's Office of Renewable Energy Programs, which operates our renewable energy leasing process, and that's what you see in this graphic on the slide here. What's really important to note here is that our process includes multiple phases of analysis and environmental reviews that span upwards of a decade before any project's construction could begin. And so this process really begins with lease planning and analysis. That's on the left side of the slide that you see here. And that's really the focus of our discussion today. So efforts within this stage of our process really inform development of offshore wind lease areas to inform an eventual auction. Once a lessee holds a lease, there are multiple stages of requirements, including site assessments and surveys, as well as development of plans that require environmental and technical reviews prior to any possible project construction on the OCS. And so for today's discussion, as I mentioned, we're really going to be focused on this first critical step of the process, which is the identification of lease areas. So the next several slides that we're going to be walking through here are intended to provide a conceptual overview of BOEM's formal regulatory process for identifying offshore wind lease areas. We're then going to follow that conceptual example up with a real-world case study example of how this process has played out in action in the Gulf of Maine region. What's important to note about our process is that it's really focused on gradual removal of areas from consideration for leasing to minimize ocean use and natural resource conflicts, while ensuring those areas that remain under consideration are viable for renewable energy development. So the boxes that you see along the top of this slide represent those stages of the process where area is continually removed from further consideration as we move towards proposed lease areas. Another detail to be aware of is that the true foundation of this process is the information that we receive along the way. That comes through public comments, through the formal commenting process. That comes through feedback from partner agencies, including other federal agencies, tribes, and states, as well as through spatial analysis. At nearly every stage of this process, BOEM holds public comment periods, as well as engagement meetings, both including virtual and in person, with affected stakeholders to really gain that additional information that's needed for the next step of the process. And so based on all of that information that BOEM receives, BOEM is tasked with the tough job of really balancing the needs of the energy requirements, offshore wind energy requirements of regional states with conflicting past, present, and future ocean uses. So the optional first step that I have shown on the screen here is the identification of a broad initial planning area on the OCS That's often developed by BOEM in coordination with the Intergovernmental Renewable Energy Task Force. And so that task force is composed of federal, tribal, state, and local government officials. And the planning area that we have on the screen here is really the result of a high level screening of the ocean area in that region. And the goal is to really define a broad area within a focal region that may be suitable for potential offshore wind development. An additional next step in the process is the publication of a request for interest, or RFI. And so that RFI helps BOEM to gauge specific interest in commercial development of renewable energy resources in that area. Is there interest in actual development of potential projects, offshore wind projects within that region? And then also to assist BOEM in determining if there's competitive interest or multiple companies that may be interested in potential development of projects in that described area. And so, as you can see, in terms of these shrinking boxes as the process moves forward, the process results in continuous reductions in area away from those areas that are less compatible towards those areas that have greatest potential compatibility with offshore wind development. So a call for information and nominations, what you see on the screen here, is really the first step that's required by BOEM's regulations. And the purpose of that call is to request comments on specific areas for special consideration and analysis. That could be like important fishing areas, conditions in the call area, specific conditions that BOEM needs to be aware of that may be present in that call area, as well as an opportunity to assess additional interest from industry in areas to be considered for leasing. Once that call is published, there's a formal comment period, and we typically also receive more comments from the task force, the public, and various stakeholder groups through meetings that are associated with that publication. And we really use those comments to further hone the planning area towards draft wind energy areas, which is the next step of the process. So from that information that we receive through the call, as well as further analysis to consider other ocean users and to reduce conflicts, we arrive at draft wind energy areas. And so these wind energy areas, or WEAs, represent a portion of the Outer Continental Shelf, OCS, that have been identified by BOEM for subsequent National Environmental Policy Act, or NEPA, environmental analysis. Those WEAs also represent the basis for subsequent lease areas. And so again, those identified WEAs have the potential for further division into lease areas. And so what are those lease areas? Those lease areas are specific areas on the Outer Continental Shelf that are subject to an auction and subsequent potential future development of offshore renewable energy projects, depending upon BOEM review and environmental analysis. And as you can see through this process, there is a continuous reduction in area, going from larger planning areas down to eventual lease areas. And the goal along that way is to reduce conflicts towards the most compatible lease areas. And so, as I shared earlier, information received from the public, from partner agencies, stakeholders, is really a cornerstone of BOEM's lease siting process, and it really drives it forward towards those least conflicted ocean areas for offshore wind leasing. On this slide, I'm showcasing some examples of what that engagement has looked like for a recent offshore wind lease planning process in the Gulf of Maine. So the map to the left here is intended to show the engagement meetings that have happened over the last several years as that planning process has progressed from that broad planning area down to proposed lease areas that were proposed earlier this year. And specifically with this planning process, BOEM engaged a wide variety of stakeholders through nearly 100 external meetings, including over 50 that were in person and focused on the Gulf of Maine. Additionally, nearly every milestone of BOEM's planning process has a written comment period associated with it. And through those written comments, BOEM often receives very specific information and details, such as important fisheries areas or data sets representing natural or cultural resources that are important to consider in the planning process. And so BOEM's tough job is really to consider all of this feedback and to balance the location across uses and resources, aiming to minimize conflict while ultimately ensuring that leases are located in areas that have potential for development for renewable energy purposes. So that's a tall order. And so one important way that we're able to improve upon that process is through employing spatial modeling. And so spatial modeling allows us to simultaneously consider a myriad of uses and natural resource considerations to objectively inform where are the most and least conflicted ocean areas for offshore wind lease siting. And so BOEM has partnered over the last several years with NOAA's National Centers for Coastal Ocean Science, which is a program within NOAA that's really focused on marine spatial planning and has expertise in this form of modeling. And what we've done with NOAA NCOS is work to develop a spatial model to inform offshore wind lease siting. So this modeling approach takes into account a broad array of spatial data. Those data represent areas of high commercial fisheries effort from NOAA Fisheries, for example. They also can represent areas that are important to safe navigation from the Coast Guard, as well as many other spatial data sets that reflect those important ocean uses and natural resources. We then take that data, apologies. Apologies, somehow my slides have gotten a little out of place there. So BOEM then takes that information in coordination with NOAA NCOS, takes all of that data that represents different uses, different natural resources, and we categorize that into what we call submodels, where we're really able to understand from an individual sector's perspective, where are the best and worst areas? You know, where are the best and worst areas from the perspective of the fishing industry's interests and concerns, as well as others. And what we're then able to do is take that feedback that we receive through our comment periods as well as our public meetings and use that information to help guide, you know, how are we actually handling that data within the submodels? How are we actually handling that individual fisheries data set or handling important areas from a natural resource perspective? This modeling framework, where we're able to look across various sectors, allows us to then integrate across all of those various sector-specific submodels to arrive at a single final map that allows us to understand what is that balance across those various uses when we're considering all of those various uses, resources, and requirements. That gives us a sense of where are those areas where there's a minimization of conflict, as well as a maximization of likelihood of success for renewable energy development. Okay, so that's how that works in a conceptual framework. But what I'd like to do now is just step through a real world example of how this process has played out in the Gulf of Maine. So in 2022, BOEM published the Gulf of Maine planning area, which was the starting point for the commercial leasing process. This area was intentionally broad and served to provide large-scale bounding parameters for the commercial leasing process that would follow. Following that planning area's publication, BOEM published the request for interest or RFI area in late 2022. And that RFI area excluded areas where offshore wind leases are legally unable to be developed, such as within national marine sanctuaries or existing traffic separation schemes. This stage of the process included a formal comment period where BOEM received public feedback that helped to guide that next step of the process, as well as it included a process where commercial interest could be indicated from prospective offshore wind developers. And again, that commercial nominations process is important because it allows BOEM to really understand if there is interest from commercial entities in potential development of offshore wind projects within the region, as well as understanding, is there that competitive interest? Are there multiple companies that have a competitive interest in development of projects within the region? So based on the feedback that we received through the comment period associated with the request for interest, BOEM worked with NOAA NCOS to conduct spatial analysis to inform a draft call area, that next step of the process. So the map that you see on the screen here shows how that feedback informed specific area removals, including removal of certain important marine habitat areas, determination of a coastal setback, as well as setbacks relative to vessel traffic separation schemes. And so after publishing the draft call area, what you see on the screen here, BOEM held a series of in-person and virtual meetings to gauge additional feedback on that draft call area. Based on the feedback that we received through those meetings, BOEM removed area from the southern edge of that draft call area to better avoid Georges Bank, which is an important commercial fishing area. And then BOEM published that call area in a call for information and nominations, which opened yet again another written comment period, as well as a convening of a meeting of the Gulf of Maine Intergovernmental Task Force. So at this stage of the process, through the call for information and nominations, BOEM received extensive public and interagency feedback that informed development of a spatial model with no end costs. And that's what you see on the screen here on that red, yellow, blue color scheme. And so that spatial model integrated 98 spatial data layers that represent natural and cultural resources, fisheries, industry and operations, as well as offshore wind considerations. And so again, that spatial model is really intended to provide a gradient of suitability, allowing us to balance across all of the various considerations that go into the planning process to identify the highest or most suitable areas for offshore wind leasing, as well as those that are the lowest or least suitable for offshore wind leasing. An additional modeling step known as a cluster analysis allows us to provide more of a quantitative method of interpreting these results to identify those least conflicted clusters of areas to advance as part of the process. And so this map shows the results of that cluster analysis, which really, again, allows you to understand where are those, from a quantitative point of view, where are those least conflicted areas, where are those best potential areas for offshore wind development based on the information that's included in the model. And the cluster analysis results, the results that you see in blue on this screen here, served as the basis for BOEM's identification of a draft wind energy area. And so utilizing those results from the spatial modeling, BOEM published the draft wind energy area in October of 2023. That draft WIA covered around 3.5 million acres and represented an almost 2/3 reduction in size from the call area stage. As part of the rollout of the draft WIA, NOAA NCOS published a draft modeling report, which included specific details about the methodology of the spatial modeling, as well as the results of the siting analysis. And the intent there was to provide transparency in terms of how is this model working, what is the information that's going into it, how is it being handled, and how is that driving the results that are informing the draft WIA stage of this process. Again, publication of the draft WIA stage here also opened another public comment period, as well as a series of meetings throughout the region. Based on feedback that BOEM received during the draft WIA comment period, BOEM worked to further enhance, further inform that spatial model with NOAA NCOS to inform the final wind energy area, or final WIA. The final WIA represents an approximately 80% reduction in area from the original call area, and is inclusive of enough area to meet the Gulf of Maine states' offshore wind energy goals, while retaining some additional area for further deconfliction. The area that you see on the screen here, the area that's green, is geographically diverse, and it includes areas within proximity of both Massachusetts and Maine, and it avoids several key fishing grounds and areas of importance for North Atlantic right whales, as well as tribal fishing grounds. Most recently, for the Gulf of Maine, BOEM announced a proposed sale notice that included 8 proposed lease areas. The amount of lease area that's proposed yields a combined capacity of 15 gigawatts, which is within the range of the region's offshore wind development goals. And those final areas avoided heavily used ground fishery areas, as well as other important fishing and habitat areas, while retaining 3 transit corridors in the southern region, as well as areas that are proximate enough to points of interconnection within the region. So the next step of this process will be the finalization of environmental analyses for leasing ahead of a lease sale in October of this year. So that presentation provides you an overview of our lease planning process, but as shared at the beginning, that is really just the first step in a much longer process ahead of any project's construction. So once leases are awarded, lessees must progress through a range of site assessment and survey activities, as well as the development of construction and operations plans with associated environmental and technical reviews. That process can take several years, and it involves collection of new data as well as additional opportunities for public input and comment. And in terms of the future for offshore wind leasing, BOEM is now required under a new requirement of the Renewable Energy Modernization Rule that became effective in July of this year to publish a 5-year leasing schedule. That's what you see on the screen here. And the intent behind that schedule is really to provide transparency to the public regarding the lease sales that are anticipated within the next 5 years, each with its own planning process that's akin to what I presented today. This also provides certainty to the offshore wind industry and the supply chain that additional projects will be on the horizon in various regions. So again, thank you for the time today. Looking forward to the questions and answers session in just a bit. And a special thank you to TNC and Tricia for the invitation.
Thanks so much for that presentation, Seth. That was great. Jocelyn, I'm going to turn it over to you now to tell us a little bit about how TNC engages in this process that Seth just outlined. Thanks.
Great, thank you. I'm assuming you can see everything okay.
Yes, you're all set.
Awesome. Thank you so much, Seth, for that really great presentation. And thank you, Trish, for the opportunity to highlight how TNC supports the siting of offshore wind. And thank you all for joining our call today. So as Trish mentioned, TNC is really focused on finding creative solutions to some of the world's most complex issues, such as addressing the climate crisis and transitioning to a renewable energy future. Now I need to figure out where all my buttons are. So just to give folks a little bit of an idea of what types of structures we're talking about, these structures here on the right are floating turbines that we're likely to see in the Gulf of Maine. And to date, we have most of our experience in the United States, at least, with these structures on the left that are monopiles or jacket foundations. So really the water depth and the composition of the seafloor is going to determine the design of the turbine that is actually used. And these technologies are really evolving rapidly. So these are not the end-all be-all options, but a sampling of what we're talking about when we're siting offshore wind in the Gulf of Maine. So determining the best place to put these turbines is really complicated, as Seth just outlined. In the Gulf of Maine, BOEM's process considered several perspectives and interests in the area that was able to winnow down a large area into these smaller lease sites. And as in the case with natural resource management in general, a lot of these decisions need to be made with imperfect data. So for instance, this is routinely done in fisheries management, where we have fish surveys that collect just a snapshot of how many fish there are in the ocean. This gives scientists the ability to use models to predict how many fish can be harvested. And that really determines how much fish we get to eat at dinner time. It's really starting with just a snapshot. So even in our day-to-day lives, we're also making decisions with imperfect information. So recently, my husband and I bought our first house, and this was a really significant decision for our family. We did our best to collect as much information as possible about the towns we were looking at, the neighborhoods we were looking at, and ultimately the houses that we looked at and the one we bought. We didn't really know, we did the best we could to come up with all the information that we needed, but we really didn't know what it was like to live in this place until we actually moved in and experienced the day-to-day rhythms of life in our home and our community. And the siting of offshore wind is really very similar to finding that perfect neighborhood where you settle down. So there are a lot of different interests in offshore wind, a lot of different interests and priorities that need to be weighed in these conversations. And I just want to acknowledge that TNC is just one voice in this process that Seth just outlined. So we engaged in a lot of formal and informal conversations throughout the process to identify the lease areas. And TNC started to really get focused on how could we provide creative solutions to support decision-making given the information that were currently available, and recognizing that there were some limitations to the data and the information, but we still could make decisions with what we had. So I'm going to give you just one small example of where we focused in on that approach. But I do want to acknowledge that we provide a lot of different recommendations on many different topics around offshore wind. And so this is just a very, very small piece. So if you didn't know, the Gulf of Maine has deep sea corals. These are structure forming corals that can be very vulnerable to disturbances. And they're also really important to the creation of habitat for other species throughout the Gulf of Maine. Some of these corals can live to be more than 100 years old, and they can create these really vast, beautiful gardens and provide habitat for many species, such as lobster and fish. However, in the Gulf of Maine, we have pretty limited observations of where corals have actually been found. To collect this information that you see in the red and yellow dots on the screen, you need a boat, you need a remotely operated vehicle, a drop camera. To collect all this information, then those data need to be processed and analyzed and cleaned, and it's a pretty labor-intensive process to actually go out and collect these observations. Additionally, many of these observations were collected about more than 20 years ago. So we have renewed efforts to that are underway right now to collect a lot more information on deep sea corals. And there are some things that we can know about the data that we have from the past. So one of the most important things that we know is that deep sea corals form clumps on the rocky habitat or hard bottom. And this information is useful in identifying priority areas where we know there's hard bottom, but we don't know if there are corals. And that means that we, the collective we, we can avoid these areas either through the siting process or through the development process once we learn a little bit more about those areas on the development side. So just one additional note, in case you're a little bit worried about the corals, offshore wind development in the Gulf of Maine will likely need to avoid hard bottom because of the proposed anchoring systems that are being considered here that I showed you on the second screen. So as it turns out, we do know a little bit more about our moon than we do know about our oceans, and data are being collected every single day, including here in the Gulf of Maine. But it can take years or decades for a lot of information to be collected and made available to decision makers. So while we wait on new data and observations to come in, as I mentioned, TNC is really looking to use creative solutions to best make use of the data we have in these processes. So what this means with regards to corals is using the information that we do have on corals in those locations that I showed you and applying those to areas where we don't have observations on corals, such as what we have here in the blue areas. And those areas can be avoided in the suitability modeling process that Seth mentioned, or it can be used in other parts of the decision-making process. So I just want to highlight that TNC is also really committed to making sure that more information is collected for deep sea corals and the seafloor in general. So we've been funding or supporting funding efforts to collect more information about the seafloor in the Gulf of Maine. And we are not doing any of this work alone. We are working through regional collaboratives and engaging with experts in the region to inform how best to utilize the existing data and the best ways for incorporating new data into the future. So I just want to thank everybody. I am really looking forward to the question and answer. I would like to thank Seth Seth a lot for coming and giving an overview of the process. It is hard to get up to speed on, and thank you all so much for joining us today. And Trish, I'll send it over to you.
Thanks, Jocelyn. So we're gonna move to the Q&A portion of our webinar. But before we do that, I just want to ask a couple of questions just to dig in a little bit deeper with you, Seth and Jocelyn. So you described this is for you, Seth. You described this really elaborate or lengthy public comment process. And I can imagine that, and I've looked at this because I've submitted comments, that you're getting lots and lots of comments and feedback and references to data that you should be looking at. And I guess I'm wondering if you can explain in a little more detail what happens immediately after that comment period closes. How does BOEM go through processing, reading, addressing all of these comments and all of the recommendations it receives?
Sure. Thanks for the question there, Tricia. Appreciate that. So as I shared during my presentation, information that BOEM receives from the public, our interagency partners, other stakeholders, really forms the foundation of what we're using to guide that decision-making process as it moves through the various stages. So as it relates to the Gulf of Maine, just as one example, we've received at each stage of the process hundreds of comments from the public and from other organizations. That often includes summaries from engagement meetings. We often have support for those engagement meetings and want to make sure that anything that was verbally shared can be summarized and sort of reflected in that record. And what we do is really work through that feedback. We identify key themes and recurring concerns, as well as in some cases, unique concerns that require special consideration. We typically work to organize that feedback, organize those comments into thematic categories, often focused on natural resource concerns such as marine habitats. Jocelyn dug deep into the concerns related to deep sea corals, or ocean use concerns such as navigation. And the organizing force that we have within this process to really integrate that feedback is the spatial model that I shared. We're able to really kind of break down all of those various concerns and various ocean uses and natural resources into separate submodels, separate sector-specific considerations. And within that modeling approach, we're really able to integrate across all of those various concerns and identify those areas that balance the various uses and natural resources. And so the way that can be sort of conveyed in terms of understanding how BOEM is reflecting upon that feedback are through the spatial modeling report. I know that was dropped into the chat. As well as we have documentation that's associated with the BOEM planning process that really captures how we're taking that valuable feedback into account and considering it at each stage of the process. I can share in terms of the Gulf of Maine, myself and several other staff have read every single comment, and we have taken a concerted effort to really work that in to that process at each step along the way.
Great, thanks, Seth. So Jocelyn, we've been talking about using the best information available to make decisions, and I'm wondering if you can talk a little bit more about what's going on with research collaboratives, partners to to fill in some of the gaps that we know exist with respect to data.
Yeah, thank you for that question. So maybe I'll take it from a regional approach and kind of come down a little bit. We have the Regional Wildlife Science Collaborative, which is a collaborative of experts in a lot of environmental issues, biological issues. It includes developers and state agencies. And there's a science plan that was developed by that collaborative to address some of the most pressing, to identify the most pressing needs for science and information that needs to be collected to support the deployment of offshore wind. And additionally, there are subgroups that really highlight some of the expertise that exists in the region. And Marta has, on our team, Marta Rivera, who's on the call today, has taken the lead on focusing a lot with the habitat group to bring forward some of the questions and concerns and conversations that I raised here today with that group of experts on how we can work together moving forward. Here in the state of Maine, I sit on the Maine Offshore Wind Research Consortium, which is a group of, it's an advisory group to the Governor's Energy Office. That includes fishermen, researchers from universities, and all types of researchers, social scientists, economists, environmental scientists, oceanographer types, as well as developers, and the state agencies have a seat on that body too. So we developed research priorities that we're looking to fund. The state legislature has provided $2 million in funding to the research consortium to answer some of the most pressing questions around offshore wind in the Gulf of Maine. And the second round of research proposals should be coming out soon, and those identify the next round of need. And then here in Maine, TNC has been working with Maine Department of Marine Resources on trying to support the Coastal Zone Mapping Initiative to really work with the fishing industry and the agency itself on collecting a lot more information around benthic habitat or seafloor data in the places where we have the biggest data gaps. And the priorities were set, those priority areas were set by the state to fill in those gaps to help inform the management of their resources.
Great, thanks. So we have just about 13 minutes before we wrap up. We have a lot of really great questions in the chat, and so I want to get to some of them now. And just to let folks know that we're going to do our best to answer all of these questions, whether they're answered live today or not. We will endeavor to provide answers to these questions. But we got this great question, which is really in line with a lot of what we've been talking about where in the planning and analysis process do key gaps in our knowledge get identified. So, we've been talking about the Gulf of Maine as an example and emphasizing what we know about fisheries. We've talked a lot about deep sea corals, and we understand that there are gaps there. But with respect to kind of other priority, and I'm taking this question to be related to like priority habitat or species concerns, where in that process do we say, oh, we have a gap in our knowledge about potential interactions here?
Sure, I can jump in here. So in terms of the process, as I laid it out, it's often a multi-year process with multiple stages where there's opportunities for public comment, as well as opportunities for meetings and further discussion. And so at the very beginning of the process, we work to identify what is that best available data, best available spatial data and information that is out there to inform the planning process. Oftentimes in those efforts, we do identify where there are data gaps and areas of need. And through coordination with our federal agency partners, oftentimes we're able to identify solutions to address those data gaps. In certain cases, there may not be quantitative data, but through the public feedback opportunities, through opportunities to review drafts of wind energy areas, for example, we're able to gain further input on certain key considerations. So, the process is set up in such a way where we're intentionally bringing into the process the best available data. We recognize often there are data gaps, but through the opportunity to sort of iterate and to gain feedback along the way, as well as partnering with our other federal agencies that have expertise in certain key issue areas, we're able to address as many of those gaps as possible. As I shared in terms of the process overall for renewable energy authorization, the lease planning process is right at the start. It's a really critical key component, but it's not all of the story. It's not the entire process. And so once a lease is awarded, there's additional work that's required in terms of additional surveys, additional site assessment activities. And that's really intended to generate new information that helps to understand those conditions within that lease area, and to really guide the process in terms of any future proposal for an offshore wind project. In many cases, we have what's known as micrositing, where, based on that really fine resolution, high resolution data on habitat conditions or archaeological resources, we're able to more precisely locate features to avoid or minimize those impacts.
Can you talk in a little bit more detail about how BOEM specifically engages with um, federally recognized tribes, indigenous people with that may have cultural concerns or historic use concerns as a particular user group?
Absolutely. So BOEM recognizes the important sovereign role of federally recognized tribes and interacts with federally recognized tribes through a government to government level of consultation. That could begin at this lease planning process stage, where along the way, as we go from a large planning area to eventual lease areas, there are formal government to government meetings and consultations that happen. Beyond that, as we move into the actual executed lease phase towards a construction operations plan, there are various considerations that are required as that process moves forward. Under Section 106 of the National Historic Preservation Act, there's a formal process for coordination with tribes and other entities as it relates to important cultural or archaeological resources. That often can include mitigation in terms of if there are anticipated impacts, specific mitigation activities, which could look like projects that would address those specific concerns. So BOEM endeavors and engages federally recognized tribes really from the beginning of the lease planning process through to the authorization of projects many years down the line.
Great. I'm going to try to combine a couple of questions here because I think that they're kind of related in my mind. But this first question is asking, like, how do we make these decisions, understanding that and accounting for possible future changes in wind speed, ocean current, fish and habitat use, climate change. Is that something that we're trying to factor in? And then there's this other question that's really talking about like these other pressures that impact habitat. And so like there are fishing boats that have dredge nets that that are scraping hard bottom. Are we tracking and monitoring these additional pressures to kind of help inform these decisions as well, or does that not play into it at this stage? And I invite either or both of you to jump in where you want.
Sure. Yeah. So BOEM's role really is to work with best available data, best available information. And oftentimes, truthfully, that looks like a perspective, a snapshot of the present, as well as sort of a look back at history. In some cases, and in particular in the Northeast region, we do have several efforts underway. NOAA Fisheries and other organizations have been leading work to try to look out into the future in terms of generating projections of where fish stocks may be in the near term. So to the extent that we're able to work that into our process, we often are. However, that's often sort of considered in more of a qualitative way. We often are mandated to work with best available data to inform the process. So, in the Northeast in particular, we are in a better spot in terms of the availability of that type of information to inform these types of processes. BOEM has funded through our environmental studies program some work that's focused on integrated ecosystem assessments. And so that work is actually looking at projecting out into the future under different climate change scenarios, changes in ecosystems. And so that work is underway. It's a bit more of a study. It's a bit more intended to inform our NEPA, our environmental assessment stages of this process into the future. But BOEM, to the extent that we're able to, is cognizant of a changing environment, particularly within the Gulf of Maine, where there's quite a bit of dynamics in terms of changes to ecosystems. So hopefully that's a little bit helpful in terms of how we're aiming to account for those considerations.
Go ahead, Jocelyn.
Yeah, thanks. I would just add that there's a Climate and Ecosystem Fisheries Initiative that is underway at NOAA Fisheries as well. And those efforts are aimed at trying to come up with, not to get super technical, but downscaled climate projections for ocean temperatures to try and start to inform how we anticipate the changes in distribution of species. I think it would be super challenging to try and make decisions in the planning process based on potential future conditions, because there's a lot of variability in what could happen. And so it may be that there are other phases in the process to incorporate some of that information to allow for adaptation to occur in how the wind turbines are monitored or they're maintained or operated. So I think trying to figure out creatively how we bring in some of those future projections and changes at other stages of the process that Seth mentioned.
Yeah, that's great additional context. And before we kind of begin to wrap up, just curious about the suitability analysis and modeling seems to apply to like the lease area itself. Is there a separate suitability analysis, or how are underwater cables going from the project to the shore considered? Is that a different phase of the review process, or is that happening at this phase as well?
Right. Great question there, Tricia. So in terms of transmission corridors, the actual easement that would allow for a transmission line to run from an offshore wind lease to a point of interconnection on land, BOEM's leases include a right for lessees to a transmission corridor without further competition, but it doesn't specify the exact location of the corridor at the time of lease execution. And so that's intentional. So often individual lessees don't know at the early stages of project development exactly which state the project will interconnect to, nor where exactly onshore the project will need to interconnect. So that does create a challenge in terms of needing to plan for that transmission corridor. And so more recently, beginning in North Carolina, BOEM's begun applying the same spatial modeling techniques that I shared in my presentation to inform transmission planning for the Carolina Long Bay lease, which is off the southern portion of the state, as well as Kitty Hawk South to the north. And the intent there is really to utilize that spatial planning information to understand, what are those best potential corridors to minimize impacts, taking into account, a wide range of factors. Transmission is certainly a challenging discussion. It moves beyond federal waters into state waters where there are additional resource and use conflicts that have to be addressed. But to the extent that BOEM's able to, we're really trying to be proactive in that planning process. And that comes at a benefit both to minimizing potential impacts, as well as in terms of false starts for any developers in terms of proposing a corridor and then needing to potentially revise that with additional survey work, that sort of thing. So it's a great question. It's a challenging topic. In particular, in the Northeast, there may be some opportunities. There's separate efforts that aren't led by BOEM that are focused on what's called a backbone transmission system, which would be a sort of an offshore technology that would allow for potentially multiple projects to interconnect offshore and then to have a single transmission line that could run to shore. So those are, at this point, more conceptual. That's not something that BOEM is leading, but there are some opportunities for innovation there. And that sort of innovation would be beneficial from the economic point of view in terms of lowering costs for multiple cables needing to be run to shore, but would also provide benefits in terms of minimizing impacts of multiple cables needing to be developed.
Yeah. That's really helpful. Thank you. We are approaching the end of our time today, so we're gonna wrap up. But I just want to ask Jocelyn and Seth if you have a quick final thought that you'd like to share.
I got
Sure.
Go ahead, Seth.
Yeah, well, I was just going to say thank you so much to TNC as well as all of you for joining today. Really appreciate the opportunity to share a bit more about our spatial planning process. I did want to alert folks that for the Central Atlantic region, just today we published the call for information and nominations for a second round of planning in the region. That can be found on BOEM's Central Atlantic webpage in terms of that federal registered notice, as well as the comment period associated with it, and information about outreach meetings that are on the horizon. So just wanted to put that onto folks' radars.
Great, thanks, Jocelyn.
Yeah, I just wanted to really thank Seth for coming. I think that what's been super helpful as I get up to speed on offshore wind and have been over the past couple of years, having partnerships with agencies and other folks that are other interested parties engaging on offshore wind, having sounding boards and expertise to rely on has been really tremendously helpful. And I just really hope that we can continue building partnerships all across the region to solve some of the issues that Seth was just talking about with transmission as well. So thanks for this opportunity.
Great. Well, thank you both so much for taking the time to present today and share your experience and expertise with us. And thank you to all of our listeners for joining us today who support TNC so generously. We will be sending everyone a follow-up email over the coming days with a link to a recording of this webinar. If you're enjoying our webinars, please be sure to share them with your friends and colleagues. You can follow us on social media at conserve_MA on Facebook and Instagram to keep up with our work and get updates on upcoming virtual opportunities to connect with us. As always, you can register for future webinars at nature.org/MA webinars. During our next webinar in this series, which will take place on September 12th at noon Standard Eastern Time, we will be talking about whales and offshore wind. And we have the great privilege of hearing from Dr. Douglas Nowacek at Duke University's Marine Science and Conservation Lab, and Jacqueline Daly, who is a fisheries biologist in the Marine Mammal Protection Program at NOAA's Office of Protected Species. We hope you can join us then. Thank you again, and have a wonderful afternoon.